So we're here today to talk about Secureable, our product for secure multi-channel authentication and secrets management, and how they fit in with OpenEdge applications. Who are Nodeable? Well, we are specialists in application lifecycle management, application architecture, Docker. We've been using Docker since 2015, maybe even before that. And we try and do everything we can in Docker. We're also specialists in DevOps, about how you can use Docker in particular to build and generate test environments and deployment cycles for your OpenEdge application. Version control and continuous integration, continuous delivery, using things like Jenkins and various other bits and pieces to tie together your releases. And one of my specialities now is security in OpenEdge and outside of OpenEdge for my sins, and we try and make something complicated very simple, and hopefully we can show you how to do this. As we said, we do everything that we can in containers. There are certain aspects of containers that OpenEdge doesn't play too well with at the moment. For example, the OpenEdge developer studio is Eclipse and GUI and it's Windows, and that doesn't play too well. But certainly databases and application servers play really nicely in containers. So what is Secureable? It's a solution for, first of all, authentication, where we can also have policies and access control lists, which you can then use to apply to your application to say who can use this feature, or which group of users can use this feature. It's also to manage and access secrets in a secure and predictable manner, where your everything is kept very secret and protected, where there's no more config files holding passwords for database connections and things like that. It also provides encryption and decryption as a service, so you can pass in data and get it encrypted and back again. And token management. With the token management, when you log into Secureable, you get a token, and that token can be valid for a period of time before automatically expiring. And one of the things with the tokens that expire is that you can store secrets on a ephemeral basis. So when your token expires, so do all the secrets that are associated with that token, and that's automatic. So you don't have to worry about that. We also do dynamic credential generation, which allows you to create on the fly credentials like username and passwords for various databases and cloud providers like AWS and Azure. So the principle of that is a person logs in using Secureable. They then have permission to generate temporary credentials to access, say, an S3 bucket. And nobody needs to know what any of the usernames or passwords are for S3. It just happens for you automatically. We have a complete set of secure REST APIs. So Secureable uses only its own APIs for, say, the user interface. So anything that you see in Secureable is also accessible through standard REST APIs. There are no secret libraries or functions hidden within the depths of the system that only the developer knows. Everything is exposed and in the open. We have written a modern UI to manage Secureable using Angular, and that's the Angular SDK that comes with Secureable. So we deliver it in either Docker or Kubernetes. There are several technologies that go into Secureable. with a bit of Node, a Postgres database, a Redis database, the Vault itself, and a couple of other things. And the whole Docker stack is just automatically configured in one stack. So it's literally one command line to bring up all the services, bring up all the databases, and plug them all together, which is pretty cool. So the use cases, we can either use it as a standalone security device, so you can put it on the network and start using it with all your applications, or as a built-in component, so you could use Secureable as a internal system within your application, or an embedded system within your own application to manage authentication and security and stuff. There's some of the technologies that we do use in the stack. So I'm going to be talking about Sliced Bread Plus during a few of these slides, and the simple answer to what is Sliced Bread Plus is your application. We talk a lot about embedding Secureable or using Secureable within an application. We just thought it'd be easier to talk about the sliced bread, because obviously your application is the best thing since sliced bread. And for our non-UK audience, basically this is the one of the wiki's explanations of what sliced bread is, and it's something that is thought to be very good, which everyone thinks their application is. So Secureable is sealed by default. Now that means it's encrypted at rest. So as soon as the service stops, the database is encrypted. Or should I say, the database is always encrypted, but when the service stops, obviously the data is still encrypted. The service provides the decryption layer on the fly. So everything comes into the service, it gets encrypted and then stored. So the storage is permanently encrypted. And when the system starts up from a shutdown, the database is sealed. In other words, you can't start this engine until some keys have been entered. Now we do this by using something called Shamir secrets, which is the key used to unlock the system is split into several parts. Each part by itself cannot unlock the system, and you need a subset of those keys in order to open it. So if we have, for example, 5 keys, and we said we want 3 keys, any 3 of those 5 keys can be used to unseal or unlock the database. Normally you distribute a key to an officer in the organization, or your boss or something like that. This is really to appease a lot of the audit people, because if some security system or security event has caused the systems to go down, you need to probably understand why it's gone down, and then and then audit who knew it was down and who gave permission for it to come back up again. Now, you can have just 1 key and this works. You can have 10 keys. That's completely up to you. Now, as I said, our default is 5 keys with 3 needed to unseal the system, and we'll do a quick demo of that a little later. And as I've already mentioned here, all the data is encrypted and secured at rest. So if someone legs it with your database, steals your database or outsources your database, it's useless because it's all encrypted. So give you a quick demo here of entering the unlock keys. This is all done through an API. So I'll just quickly do this. When the system starts, you see that you need to, it tells you need to enter the unlock keys. So really all we do is we enter the first key, which is, you can see a long set of digits there. It now says we've entered one of 3 keys. So the system knows how many keys we need. We've entered the second one now. And finally, when you enter the third one, the system is then unlocked. Yeah, it really is that simple, simple to do. The nice thing is each of those keys can be entered by people in different rooms or across the world or something like that. So the system listens for a key being entered and will notify the person who's trying to unlock it that a key has been entered with that. So a user can authenticate to Secureable in a number of ways, either by the standard username and password, which you're all grown to love in OpenEdge, or through Active Directory, Kerberos. It is a bit of a pain to set up, but Secureable can support Kerberos for true SSO. So if you've logged into Windows, when you start go into Secureable and get a token, it automatically generates that token for you because it's identified with Active Directory that you have already logged in. OIDC or OpenID for Azure, Office 365, Google, Auth0, and various or a number of organizations provide OIDC authentication. Either with certificates, you can have a public-private certificate, radius. Client ID and secret, which are used for applications or engines rather than username and password. The difference between username and password and the client ID and secret is that the username and password has a user, whereas the client ID is just a token. So it's not registered to any particular entity, but it is a valid token. And PASOE or any REST-based application, you can set up Secureable to make a HTTP request to verify a username and password, which means that you can start plugging in any HTTP application like PASOE if you wanted to put the burden of authentication onto that particular REST application. When we're talking about PASOE in a normal Secureable sense, PASOE authenticates with Secureable to get the client principal certificate. The important thing here is that a user can have more than one authentication account. So you can set up the user to have Active Directory, username and password, and various other authentications. And no matter which one they log in with, they get identified as that particular user. So it's always a way of amalgamating the various login protocols, which is again quite useful if your Active Directory is down or you want to log in with certain with just username and passwords because you don't have access to the Active Directory at that time. It's really useful that way. Is a brief screenshot of a number of things. On the left-hand side, you can see the provider's screenshot, which shows you for this particular user or admin that they have a Secureable authentication provider and a TOTP authentication provider. Now, in the main screenshot here, you see the TOTP provider. I've only called it TOTP because we have multi-factor authentication capabilities as well. So in this particular case, we're using a time-based OTP, much like the Google Authenticator that you have on your phones, for example, that gives a 5 or 6 digit number that changes every 30 seconds, every minute, depending on how you configured it. And in this particular instance, we're using the time-based one. We also have a FIDO or a YubiKey authentication multi-factor device, so that you can just use your fingerprint to identify who you are. So as we mentioned here, we have the FIDO, the WebAuthn, and time-based stuff. At the moment, they're going to be associated with either username, password, and LDAP or Active Directory. The reason being someone like Google or Azure may also implement their own FIDO capabilities. We then don't care about that. All we do is we authenticate with Google. If Google then requires you to enter your biometrics, passwords or eyeballs, whatever they are, then we only get a response back from Google once you've done that, but at least we know that you have been through that process. There's a quick demo here of the TOTP login. So we're choosing our login, we're entering our password. The first time a user logs in on that provider, it gives them the barcode that they can enter in the Google Authentication app to register. And obviously once they're registered, then the code now works. So the first time we logged in, we've now registered and we're entering the code. And you can see we've logged in here with access to the screen. If we log out again now and then log in again, this time we don't see the barcode because it is already registered and we just need to enter the code. And yeah, this is quite common now on a lot of websites, this sort of thing. Rather than using SMS, which can be vulnerable to spoofing or man-in-the-middle attacks, this is much more secure for that sort of process. Okay. Next one, we've got a quick demo of the FIDO login or the WebAuthn login. This time we're logging in with admin at Secureable, same user, but just a different provider. And this time, so when we enter the password, the Chrome browser now asks us to enter the PIN for our key, asks us to touch the security key, and then we're logged in. Again, just another way of, excuse me, multi-factor login, which is all built into the application, which is pretty cool. Coming on to secrets, a secret can be classified as anything that is sensitive. API keys or passwords, certificates. In this case, you could store your IAM or AWS credentials in there, SSL keys, the list goes on. And basically, it's anything that can cause a problem if that information is revealed. Too many times now, there's been a conflict of where to put your credentials when you need to connect to a third-party service. For example, you need, how do you know which OpenEdge database to connect to? Well, you have a PF file, and that PF file sometimes has your passwords in it. So then someone has to manage that config file. Same for anything, S3 buckets or Elasticsearch credentials, Active Directory credentials, anything like that. And one of the problems is at some stage, if you store that stuff in a configuration file, it will end up in your source code because somebody will check it in at some stage. There was a incident with the DJI drones a couple of years ago where someone managed to check in the key to unlock the firmware, and all of a sudden all the firmware of the DJIs could be remotely changed, which was quite funky. So how do we manage this? Well, Secureable provides a single source. So not only do you log in with Secureable, but then you use that token that you've logged in with to access the secrets that you've been given permission to do so, which allows you to define a whole raft of permissions which user can access which secrets, which again is more than useful, because at the moment, sometimes if you've got a config file, it's there, and anyone who can read the disk or can see this can see those secrets. We also provide operator access to allow you to define who can access what and what actions they can perform. So not only can you say who can access the user API, can they create, update, read, delete, list, all the verbs on that particular point. We also have detailed audit logs, who's accessed what, where, and when. And as I keep saying, the data is encrypted at rest, which is very, very important. So your application /bread plus may require access to something like database credentials, API keys for external services like AWS, service-oriented architecture, for example, your RabbitMQ or your Sonic connections. Anything really, any particular secret. The list can go on. So how do we do this? Well, anyone who's tried to do it and do it well knows that managing access and managing secrets is very hard. It is horribly hard. And a lot of the times there's these clever hackers find ways around stuff that you just didn't think of. And whilst you applaud their ingenuity, it's a real problem to try and keep ahead of them. So this is where you start using key rolling to rotate your keys so that every week the encryption key is different. So it doesn't matter if they break into it because it's a week old, etc., etc. What cipher to use, what protocols to use, what secure storage do you use? How do you store this data in the logs without revealing information? What a lot of people tend not to know or find out to their cost. For example, if you have query parameters on a URL, a lot of web servers store they don't store the body of the request, but they do store the URL. And if you send your query, your username and password, for example, as a query parameter, it will end up in a log somewhere, which, yeah, again, could not be good. How do you maintain a secret for how long it lasts, or a token for how long it lasts? How do you manage the revoking of those things? And this is where Secureable steps in. We do this for you. The secrets can be stored as a key value, much like a JSON object. It can be up to any length. We do set a limit at the moment of 32 megabytes per secret, which is probably a fair and reasonable value. The data is encrypted prior to writing to the persistent storage, so before it hits the disk, it's already encrypted. And that means by gaining access to the raw storage, i.e. someone nicking your database, it isn't enough, because you need to be able to enter 3 out of 5 or 7 out of 9 or 13 out of 15 unlock keys to be able to do that. Much like a folder system, so you can say A, B, C, D, E, and just work your way down the folder. And each portion of the path has its own permissions. So you can say that users A, B, and C can access this part, users D, E, and F can access this part, and they're not transposed. So each permission is assigned to what we call a policy. A policy is a collection of capabilities. A capability is a list of permissions or a list of actions on a particular path. And the policies are assigned to a user group, and users are assigned to user group, and therefore you can say this policy, which is a collection of capabilities, is assigned to anyone in this group. So moving on to dynamic credentials, we can generate them on demand for a number of systems. Things like AWS, SQL databases, Azure, S3, Google Cloud, which allows you to provide access to these services to a user without the user knowing the credentials needed to access them, which is quite powerful. So they log in, and because the administrator has given them a policy that allows them to create some credentials, they can then log on to S3 without knowing anything. So in this particular case, the /bread application calls the Secureable S3 API for credentials. We generate the AWS key pair on demand with the appropriate permissions based on the role that user has access to. So we say that you can say, for example, that departmental managers have access to the role called head, which allows them more permissions on S3, whereas a programmer only has access to a folder way within that, or maybe only read-only permissions. So you can be very, very fine-grained with the way that you access these things. And again, it has to be stressed that neither the department heads or the programmers need to know anything about any of the AWS credentials, because they're just given them automatically. So we make the calls to S3, and we generate the credentials for S3, and then /bread can then call S3 using those credentials. And when the token expires, we expire those credentials, or when you set them up, you can set up a time to live for these credentials. So you can say that when your application needs to access S3, for example, this set of credentials is only valid for 10 seconds or 5 seconds or 10 minutes. Again, that's up to you. And again, the shorter a credential is available or is valid, is obviously more and more secure. If you create a credential that's valid for a year, then for a year, anyone who gets hold of those credentials can do something. Whereas if it's only valid for 10 seconds, it doesn't really matter if someone finds them then, because they're invalid. No more master passwords or configs or credentials in source code. You don't need them anymore. So when we say they're created dynamically, when you set it up, you supply the client ID and secret required, or the admin does, in order to be able to generate these credentials. But once that's done, it's then hidden from everybody. Nobody knows any of these details. And as I've mentioned, we can provide different and limited access credentials based on the user policies and the roles. Generated on demand when needed. So it's not that you have to set it up prior in advance. If a user logs on or wants to do something, then those credentials are created for them on the fly at the time. And we have, as I say, a full audit trail to identify any point of compromise. I like to say, just like my slides, created just in time, right before you need them. Which anyway, encryption. We do provide an encryption and decryption service on the fly, because again, encrypting data is very, very hard. It is very difficult to do right. You can set up your security teams to define the level and the algorithms used of encryption. As I say, there's various types there, including RSA 496 or AES 256. Nonce is context convergence and other funky terms. You don't need to worry about them. We handle it for you. Now, I know in the UK, nonce has a different term. So for all of the UK viewers, please stop tittering and chuckling to yourself right now. It is a security term, and nonce is a security term, I promise you. So sliced bread can store the encrypted data in the OpenEdge database. So sliced bread makes a call out to Secureable saying, I want to encrypt this data. It gets back base64 encoded encrypted data, which you can then just shove into the database. So then you have encrypted at rest and at access data. So you could decide that you want to encrypt a certain column or a record or whatever you want. As long as you can store it in the OpenEdge database, you're fine. And there's no need to design your own encryption mechanisms and store secret keys everywhere in config files and stuff like that. You don't need encryption libraries and DLLs. So now you can start encrypting your data with a cross-platform capability. So the Windows DLLs or stuff like that, you're not limited to having to support that. And your data is now encrypted at rest. Something called convergent encryption allows you to encrypt the same data and get the same result back, which is useful if you're wanting to, for example, let's say there's you want to encrypt the postcode of customers. So for GDPR purposes, for GDPR purposes, you're storing their data securely. It doesn't help if you want to do a search on the database. But what then the conversion encryption allows you to do, of course, is you can take the postcode that the user enters for the search, encrypt it, and then search on your database for that encrypted value. So it's at least that way you can store data and not compromise any of the functionality of your application. So normally what you do is you select an encryption key, you type your data that you want to encrypt, and then you get the data back. When you want to do it the other way around, you enter the encrypted data and you get your decrypted data back. Again, we're going to do a quick little demo of this here. So I'm just going to encrypt the data. So we choose the encryption key. I've chosen a key called Poet. Just type in, any plain text, so the quick brown fox. You then encrypt it, and you get the encrypted data back. Very, very quick, very fast, very simple. Copy the data, because we're just going to reverse the process now. So we're now going to select the same key, enter the data to decrypt, and what's the result that we get back? So, password and passphrase generation. Again, generating secure passwords. When you want to suggest a secure password to someone, is very hard. It's very difficult. And again, we have you covered. Again, very, very simple APIs to call to generate either passwords or passphrases. Setting up the rules that you want to do for this. So in this screenshot, you can see we want to generate a password of 36 characters with 10 digits and 5 symbols. And there's your result. Or a 3-worded phrase separated by a dash. It's all very, very simple. I'll show you how reasonably fast this is to do. So again, we just want to generate something. I'm going to change that length to 20. And you can see the data is there, being copied very quickly. You can change the digits, or go into the passphrase now. So you can see that we can easily just generate that data as and when needed. So your application can now call out to Secureable and get this password, get this passphrase that you need, all very, very simply. We have an Angular SDK that's generated for you, so you can embed a lot of the complexities of the API. We've provided helpers for, so you can just say, call login, and the Angular SDK handles all of that. We've written it in the management interface in a Angular application, and we use the Angular SDK to access Secureable. So we're constantly dog fooding our own SDKs. We support Angular 8 to 12 for the SDK, which is handy. We also have a ABL SDK, which if you've seen one of the presentations I gave slightly later, it was about how we came to build all of this. But within your application, you can now call or use the SDK to make simple, easy calls to the Secureable application. So now our sliced bread app, or your sliced bread app, can integrate with the Pro library. If you're coming in through a PASOE instance, so your application's a PASOE, you will automatically have a sealed client principal with all the user's information in it that you need, because the way that we've set it up is that when you authenticate through Secureable using PASOE, we use a Spring security, and that automatically generates your client principal for you. If you're not using PASOE, you can still use Secureable to log in, to get tokens, to get your data, and create a client principal that way. Now you can both have metadata stored in that, so you can define what data you want sealed inside your client principal, which is very useful to have. So for PASOE, we just use the common Spring configuration, and we basically say it's one config to rule them all, because what we allow you to do is, because you're logging into Secureable, you can use any number of the methods to log into Secureable, so OIDC or Active Directory, LDAP, SAML. You can even use Kubernetes to authenticate if you wanted to. But as far as PASOE is concerned, it's only one authentication, and that's OIDC. So we generate a JWT, or a JavaScript web token, that is supplied to PASOE, which it then verifies and identifies you and validates you as a user, and then Spring creates client principal and passes it into your application. And it is really, really simple, because the properties file is automatically generated by Secureable. So you just need to make one unauthenticated REST API call to Secureable to say, I want the configuration file for a PASOE application, please. And whether it's 11.7, 12, we will then generate the appropriate configuration file for you, which you can then just paste, start up your Spring security, and you then integrated Secureable with PASOE. So it's a very, very simple load and go process. Quick look at the capabilities and policies. So a capability is what action you can take on a path. What can be done on this particular endpoint. Policy is a collection of capabilities. So you can build up, this one policy has read-write access to this, delete access to that, and so on and so forth. And the policy then defines which of the capabilities actions are allowed. So it's the policy that defines the permission. The capability says you're capable of doing this. The policy says you are doing this. And then when you have a user group, you can have any number of policies assigned to a user group, which then means, of course, that you can mix and match to your heart's content. Now we work on the basis of most restrictive wins. So if you have, which we'll come to the next slide, but if you have conflicting permissions on a path, the one with least permission wins. So you can't accidentally grant someone access if you've granted 0 access before. This is basically just a little capability thing. So you can see here that we have a create, read, update, delete list option. So you have 5 actions per path. We allow you to define a label for each one, just in case you don't want to use create. In this case, we're just saying send. And then when we allocate it to the policy here, you can see here the policy is saying, what actions do you have? And the capability is saying, I've got send. And you can then choose whether you want that capability or not. So a path can have wildcards. It's in quotes because it's not proper regex or regex at the moment, which is unfortunate. So a star is everything after this. So you can't say star a star because you can't. And you can have a plus for a segment of a path. So if you can have a/plus/c, anything in between paths A and C is valid. As I mentioned, most restrictive wins. So these 3 options here, your foobar read policy takes precedence because it's the most restrictive. So to get a path capability, and the capabilities, you can maintain your own, create your own for your own paths and things. So they're useful for not only controlling access to, say, API paths, but you could also define functionality paths or UI paths just as a set of a tree folder. So you can say that this button is not available to this user, or it's read only to this user, which again can be quite helpful when building your UI, because now everything is consistent. You just make a call to Secureable to say, I have these paths, which is a widget tree, and Secureable goes, yes, 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 no, yes, yes, no, no, no. And then you can set up the UI according to those permissions. And again, it's automatically created based on your user groups and policies. And because you can create your own capabilities and your own policies, you can create whatever ACL paths you want for your application. Secureable has a pure REST API, but it's written to OpenAPI standards. So we have what used to be called Swagger. We have a Swagger endpoint that defines all of the endpoints, which means that you can be called from ABL or curl or browser or any application that uses HTTP protocol. There are certain things that have to be done through a browser. So, for example, Google Authentication or OpenID authentication has to be done that way. Again, no secret calls or libraries. We're using the OpenAPI 3.0 path, and we have a built-in Swagger definition. So it's not that we have to keep the definitions up to date. When we add a new API or make modifications to an API, which won't be that often, when the server starts up or when the Secureable server starts up, we automatically generate the Swagger UI on startup, so it's always up to date. So that's a basic screenshot of the API. We've got a quick demo on the next page about doing some bits and pieces. So you can see here, for example, that it's all documented to say that we need separator, we need words for this post to the passphrase API. And there's our response from that. We supply the curl equivalent of this API, so it's actually quite nicely documented. If you're wanting to know what to use, go to OpenAPI, enter the parameters, and it generates the curl for you, which you can then use in your other scripts and stuff. So here's just basically a very quick demo of that. We're authorizing, so we're going to enter a token, which is the secure token we get when we log in. So now we're authorized, and we can choose now any of the API calls. The first one we're going to have a quick look at is the current counters, which tells us how many active users and active tokens have been used this current month and stuff like that. So you can see we've executed that call, we've got the data back, and we have the curl response at the top there. Let's have a look at the generate passphrase thing again. Again, we're going to try it out. We're going to enter some details. We want to separate it to be a star, and we're going to have 4 words. And when we generate, you can see that we're getting the data back very, very quickly. Browsing down a little bit further past all these API calls, we also document all the models that, all the payloads and responses that come back from Secureable. So the init payload has those values, and the init response has these properties. And as I said, that's all automatically generated and managed for us, which is very, very useful. Some of the technology we use in Secureable, obviously have our Secureable application. It's all written in TypeScript on Node using Nest.js with a type ORM database layer. We do use Postgres as the back end, and Vault and Redis for various bits and pieces. Angular SDK makes things very useful, documented as well. So we have a login response there. You can see what's needed, what's required. So their check token is valid. So rather than you writing this code to access this API, it's all available in Angular classes and services as such. The ABL SDK is very, very simple. It's basically a collection of classes with built-in conversions to and from JSON. So you just call the ABL SDK to say, I want to log in. You pass the payload and you get a class back, or a class instance of a class back, which is really helpful and useful. So you don't need to worry about the HTTP side. You don't need to worry about marshalling the data in and out. You don't need to worry about the JSON side. It just all happens. So this is an example of the a login procedure. So we're setting the URL to Secureable. We're setting the payload. Oops. We're setting the payload. We're setting so we're creating a new class. We're populating that class with the username and password. We're then creating a new login service and performing the login, because it's fluent application. And then you can see that the result is an instance of the class, because we can just look at the token from that login. That's really about it. I don't go too much over the time. I hope you find this useful, and if you want any further information, please visit our website at Nodeable.io and have a look at some of the data sheets there, or just get in touch. My email's on the cover slide. Thank you for watching. Any further questions, please get in touch. Thank you.